Now another iteration method, Gauss Seidal iteration method. Gauss Seidal iteration method. Okay. Now what is the change between Gauss Seidal and Gauss Jacobi? Here in this method, we use the updated values of x1, x2 and so on, xi minus 1 in computing the value of the variable xi. What is meant by updated values? For example, in the first iteration, okay, let me explain in the method clearly. Okay, for this, consider the system. To explain the concept, let me consider 3 by 3. Consider the system Ax equal to b as a11 equal to x1, a11 x1 plus a12 x2 plus a13 x3 equal to b1, a21 x1 plus a22 x2 plus a23 x3 equal to b2. Next one, a31 x1 plus a32 x2 plus a33 x3 equal to b3. And remember, here this is system 1 ax equal to b, here the diagonal elements, that is a not equals to 0, to get the diagonal dominance property. Okay, now what happens here? From the first expression, if assume diagonal dominance exist in the system. What is the meaning of diagonal dominance in the system? Means what? This a11, a22, a33 are more than sum of this a12 plus a13, a21 plus a23, a31 plus a32, right? You know this diagonal dominance property. Now what from the first expression, now using first equation, I can write x1 equal to a11 by minus a11 by a11 minus a12 x2 minus a13 x3. Similarly, using second equation, x2 equal to 1 by a22, this is b2 minus a21 x1 minus a23 x3, and next one, from the using third equation, write x3 equal to 1 by a33 of b3 minus a31 x1 minus a32 x2. Okay, using diagonal dominance property, and we are writing the diagonal variables x1, x2, x3 in this manner. Now what happened here? The Gauss Seidal iteration procedure is then Gauss Seidal iterative process or procedure for the first iteration. Let me explain this one. For the first iteration is, in brackets, assume initial approximation as x1 at a 0 level, x1 0, x2 0 and x3 0. These are the initial approximations. Then see what is the first approximation. I'm writing here x1 value at the first approximation is 1 by a11 b1 minus A12. I know x2 value at 0th level, so 0, and x3 value also I know initial approximation only x3, 0. Done. And now the change is, see, observe here, x2 value at first iteration 1 by a22, 1 by a22, b2 minus a21. Now x1, I know x1 at first level, therefore this is the updated value. Use the updated value x1 at first iteration. Now a23, x3 value I know only at 0th iteration. Now this is the change, this is the change. Okay, and I will write here itself, x3 value at first iteration is 1 by a33, okay, b3 minus a31, x1 value I know first iteration, and similarly a32, now I know x2 value at first iteration, therefore this is x2 value at first iteration. This is the change between this one, first iteration values, change between Gauss-Jacobi method and Seidel method. In Gauss-Jacobi method, what is the idea? First iteration values are obtained by replacing 0th iteration values directly, but here we are using updated values subsequently. Okay, and that is why the Gauss-Seidel method is called as successive replacement method. Successive replacement method. This is first iteration. In general, let me write in general. In general, Gauss-Seidel iterative formula. Gauss-Seidel iterative formula is, okay, now I am writing the formula. X1 value at k plus 1th iteration is what? 1 over a11, b1 minus a12 x2 at kth iteration, a13 x3 at kth iteration, right? Now x2 value at k plus 1th iteration is equal to 1 by a22, 1 by a22 b2 minus, this is what, a21 x1 minus x1 at what level? K plus 1th level, because I know this value. Okay, and this is a23 x3, I know x3 value only at kth iteration, and third one x3 at k plus 1th iteration is 1 by a33, this b3 minus a31, now I know x1 value at k plus 1th iteration, so replace it, and a32 x2 value also I know at k plus 1th iteration. This is Gauss-Seidel iterative formula. Gauss-Seidel iterative formula. Okay, now we may rewrite this formula as, see, let me write directly. And what is this method is also called as Gauss-Seidel. Gauss-Seidel method is also called as method of successive displacement. Method of successive displacement. Method of successive displacement. Okay, because successive approximations are immediately replaced. Now this is Gauss-Seidel method. Let me explain in matrix form. Gauss-Seidel method in matrix form. Gauss-Seidel in matrix form. In matrix form. Okay, what is that? Gauss-Seidel method in matrix form. Right. Okay. In matrix form. GS stands for Gauss-Seidel method. Gauss-Seidel method is given by, you have to remember the formula, that's it, D plus L. You know, D stands for diagonal matrix, L stands for lower triangular matrix of xk plus 1 equal to minus u xk plus b, or this implies one can write what is xk plus 1 becomes, take d plus l onto that side, so minus d plus l whole inverse u xk plus d plus l whole inverse b, d plus l whole inverse b. This is of what form? Actually you have to remember this, or one can write like this, xk plus 1 equal to, this is matrix H of xk plus c, xk plus c, where k is from 0 1 2 and so on, 0 1 2 so on, where what is h value? H value is minus d plus l whole inverse u, and what is c value? Column vector is d plus l whole inverse b. Remember this formula, okay? Or you remember this formula where h is this value and c is this value. This is matrix form of Gauss Seidal method. Now error format. To get error format, Gauss Seidal formula in error format, okay? What is that? The above equation, what is that equation? You write like this, the matrix form xk plus 1 equal to minus d plus l whole inverse u xk plus d plus l whole inverse b can be written as xk plus 1, k plus 1 iteration equal to, okay? Let us add and subtract xk minus xk minus d plus l whole inverse u xk plus d plus l whole inverse b. Now club one second xk into clubbing these two terms, and taking minus also common, minus xk common, this is I plus d plus l whole inverse u of xk, isn't it right? Plus d plus l whole inverse b, okay? That is equal to xk, and what is the common here? Now take d plus l inverse common, d plus l inverse common, so this becomes I becomes what? D plus l to get I value plus u of xk plus d plus l inverse b, that is equal to xk, right, minus d plus l inverse, and what is this entire value? L plus d plus u is nothing but a, so a x power k plus d plus l inverse b, Now this d plus l inverse common, then what is this becomes? This is equal to xk minus, or take plus term common, d plus l inverse common, so what is the remaining part is first plus term being minus a x power k. Same procedure as in Gauss-Jacobi method, this is the expression of xk plus 1, okay? Then assume this one, what is b minus axk r power k, right? Therefore, and one more thing, now let v power k equal to d plus l inverse r power k, or we write better, let me explain one more time. What is this? Let vk equal to xk plus 1 minus xk and rk as same notations as in Gauss-Jacobi method, b minus a xk. Then what we have previously, xk plus 1 the previous equation, taking xk onto the left side, is equal to d plus l inverse of b minus a xk, right? That implies what is this? Is this value is v power k equal to this d plus l whole inverse as it is, and this is what? R power k. This is what? R power k. Done? Okay. Therefore, this implies I can write this as, take d plus l onto this side, so vk equal to R power k, isn't it? Right? So this is error format. Solve for vk. Solve for vk by forward substitution. By forward substitution, you will get a upper triangular matrix here. Forward substitution. Then what is xk plus 1 equal to? From this expression xk plus 1 equal to xk plus vk is the solution. Okay, this is error format. This equation is error format. That's it. This is error format of Gauss Seidal method. Now consider one problem based on Gauss Seidal method. Solve the system 2x1 minus x2 equal to 7 minus x1 plus 2x2 minus x3 equal to 1 minus x2 plus 2x3 equal to 1 using Gauss Seidal method. Using Gauss Seidal method in matrix form and in error format Take initial approximation. Take initial approximation as x0 equal to 0 and perform 3 iterations. Okay. Solution. What is the quotient matrix A here? 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2, and B is what? 7 1 1. Clearly here, the system is diagonally dominant. Isn't it, right? This 2 more than other quotients, right? Diagonal dominant. Therefore, now matrix form. Now what is the matrix form? Xk plus 1 equal to minus d plus l inverse u xk plus d plus l whole inverse b. So first let us find LDU here. What is L? Lower triangular matrix. Remember, lower triangular matrix with 0 diagonal values. Lower triangular matrix means only lower elements will be there, so remaining position 0 in this one, right? Next, diagonal matrix 2 2 2 and remaining position zeros, and upper triangular matrix here 0 0 0. Upper elements only are there in A, 0 minus 1, remaining are zeros. But here what we need? The matrix D plus L is required. So D plus L matrix is what? Add these two, D and L. This is 2 0 0 minus 1 2 0 0 minus 1 2. This is D plus L, right? And U matrix already it is there. And what is required matrix? One more is D plus L inverse is required. So what is the formula? Adjoint of D plus L by determinant of D plus L. You can calculate this. Okay. And D plus L inverse is what? 1 by 2 0 0 1 by 4 1 by 2 0 1 by 8 1 by 4 1 by 2. This is D plus L inverse. Now What is the matrix form? Gauss Seidal method in matrix form is what is the formula? Xk plus 1 equal to h into xk plus c, where this is, take this as 1, where what is H matrix? H matrix is what? Minus D plus L inverse U. And what is C matrix? D plus L inverse B, right? Therefore, first let us find D plus L inverse H. Therefore, H equal to minus of D plus L inverse U. Let us find this. So this value is what? U matrix, you know already. Okay, yeah, minus is there. So after taking this matrix D plus L inverse, this is 1 by 2, minus will be there, 0 0 1 by 4, all are calculations, so just I am writing D plus L inverse matrix and a U matrix. What is U matrix? 0 0 0 minus 1 0 0 0, right? This entire product gives 0 minus 1 by 2 0, 0 minus 1 by 4 minus 1 by 2, 0 minus 1 by 8 minus 1 by 4. Okay, next one more find. Let us find C equal to D plus L whole inverse B, that is D plus whole inverse, right? 1 by 8, 1 by 4, 1 by 2, and B matrix. What is the right hand side matrix? 7 1 1, 7 1 1. This is equal to what? 7 by 2, 9 by 4, 13 by 8, 13 by 8. Therefore, what is equation 1 implies? Xk plus 1 is equal to, what is this matrix? Okay, these are all plus. After multiplication by minus, these are all plus. So 0 1 by 2, 0 0 1 by 4, 1 by 2, 0 1 by 8, 1 by 4 of xk, of x power k, xk plus 7 by 2, 9 by 4, 13 by 8. This is 2. Now let us put k values. K equal to 0 1 2 and so on, right? 3 iterations. Now let us see what is when k equals to 0. When k equals to 0, x1 is equals to what? This 0 1 by 2 0 0 1 by 4 1 by 2 0 1 by 8 1 by 4 of x0 plus, what is the matrix? C matrix, 7 by 2 9 by 4 13 by 8. And what is the given? x0 0 is given. Therefore, what is x1? 7 by 2 9 by 4 13 by 8. This is x1 in bracket. Since x0 is given as 0, that means x1 0, x2 0, x3 0. This is x1 value. So what is x1? We are getting x1 equal to 3 by 7 by 2, 3.5, 2.25, 1.625. Next, when k equals to 1, x2 equal to 0 1 by 2 0, 1 by 4 1 by 2 0, 1 by 8 1 by 4, x1 plus the same value, 7 by 2 9 by 4 13 by 8. Now what is x1? Substitute x1 value here. X1 is here. Substituting x1 and simplifying, we are getting x2 as 4.625, 3.625, 2.3125, 3.213125. Next, lastly, third iteration, when k equals to 2, that is x3 equals to, same matrix, 0 1 by 2 0, 1 by 4 1 by 2, 1 by 8 1 by 4 of what? x2. I know x2 value here. Substitute that, and this is 7 by 2 9 by 4 13 by 8 This is equal to what? The solution is 5.3125, 4.3125 and 2.6563. This is third iteration value. Okay, right? Now error format. Gauss Seidal in error format. Gauss Seidal in error format. What is the formula Gauss Seidal in error format? Vk equal to d plus L whole inverse r power k. Where this is the formula where Vk is nothing but what? Xk plus 1 minus xk, and rk is nothing but what? B minus a xk. That's it. Remember this, right? Now for our problem, let us implement this error format. First thing, what is given? Given x is 0 equal to 0, right? Now first iteration, when k equals to 0, let us find first v0. When k equals to 0, v0 equal to d plus L whole inverse r0. T plus L whole inverse r0, where what is r0? R0 equal to b minus ax0, and what is ax0? B, right? Therefore b value you will get, okay, that is 7, right hand side matrix starting. Okay, therefore what is v naught? D plus L whole inverse is what? 1 by 2 0 0, 1 by 4 1 by 2 0, 1 by 8 1 by 4 1 by 2. D plus L inverse, and R0 is what? 711. So this value is what? 3.5, 2.25, 1.625, 1.625. Therefore what is xk plus 1 equal to? Xk plus 1 equal to xk plus vk. Xk plus vk from this expression, right? This implies the first x1 when k equals to 0, x1 equal to x0 plus v0. Since x0 is 0, what is v0? So what is x1 value? 3.5, 2.25, 1.625 in bracket, since x0 is 0. Okay, this is x1 is over. Now coming to when k equals to 1, let me find first r1. What is r1? B minus ax1. B minus ax1. So b means what? 711 minus a value, the matrix A, 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2 a. What is x1? We got previous first iteration 3.5, 2.25, 1.625. So after taking this one, we are getting entire value r1 as 2.25, 1.625 and 0. Therefore what is v1? V1 is what? D plus L inverse r power 1. And you know what is D plus L inverse? Again 1 by 2 0 0, 1 by 4 1 by 2 0, 1 by 8 1 by 4 1 by 2. And what is r1 value? 2.25, 1.625, 0. That is equal to, what is this? v1 1.125, 1.375, 0.6875. okay, therefore what is x2 value? x1 plus v1. x1 plus v1. What is x1? x1 2.25, 1.625, 0 plus v1. v1 is what? 1.125, 1.375, 6875. So summing these two matrices, we are getting x2 as 4.625, 3.625. In both methods you will get same result, 3125. okay, this is second iteration. Next, third iteration, final, when k equals to 2, r2. R2 is what? B minus A x2. You substitute all the values. Directly I am giving R2 value. Substitute B matrix 711 minus matrix A 2 minus 1 0 minus 1 2 minus 1 0 minus 1 2. And what is x2 value? 4.625, 3.625, 2.3125. This gives R2 value as 1.375, 0.6875 and 0. R2 is over. Then next V2. Now V2 equal to what? D plus L inverse R2, right? And you know what is D plus L inverse? 1 by 2, 0, 0, 1 by 4, 1 by 2, 0, 1 by 8, 1 by 4, 1 by 2, R2. Just now we calculated R2. What is 1.375, 0.6875, 0. So taking multiplication, we are getting V2 as 0.6875, 0.6875, 0.3438. Now finally, now what is x3? X3 equal to what? X2 plus V2. And what is x2? We are getting, we have x2 is 4.625, 3.625 and 2.3125 plus V2 0.6875, 0.6875, 0.3438. This gives the final third iteration value 5.3125, 4.3125, 2.6563. This is the answer. This is error format.